All right, students. So this week we're gonna talk. Sorry about that. We're gonna talk about an introduction to the Pythagoras, the theorem of Pythagoras. So Pythagoras was an ancient Greek that thought of this, and now we use it as a theorem. Most schools we learn it as a squared plus b squared equals c squared. I'll tell you what that means. So the theorem of Pythagoras talks about, it makes reference to right angled triangles. So where the longest side right here, which is opposite to the 90-degree angle, it's called the hypotenuse. Think of it like a hippo. Anyway, so what the theorem says, it says it right here, is that the area of the square on the hypotenuse is equal to the sum of the areas of the squares on the two shorter sides. So the area of this big square over here, which is the biggest square, is equal to the areas of the squares over here on the sides. Now, think of areas, right? Areas, the area of a square is, the formula is this, right? So we're talking about the area of this equals the area of that. So that's pretty much what it says, okay? And we use this formula, a squared plus b squared. So area of A, area of B equals area of C. So notice that these are two squared, right? They're squared, all of it, okay? All right, so that's a little introduction of what we're looking at, the theorem of Pythagoras. So Pythagoras theorem, we call it Pythagorean theorem or Pythagoras theorem, whatever you want to. Sometimes, this is a perfect example here. So sometimes you gotta look for this one. So you use a formula to find missing sides. In this case, you're looking for c squared, right? So you have a, so a squared plus b squared equals c squared. So a squared, so that's 9. B squared is 16, so that plus that. And then when you remember that you are to take the square, to undo this problem here, you have to take the square root, and the square root of 25 is 5, and that's all you're doing here, pretty much. Anyways, let's do some actual examples. Okay, so sometimes you'll see this in the triangles, and sometimes you'll get actual the values for each of the sides, but you have to know which one goes with which, and you always have to use a squared plus b squared equals c squared. Okay, so this is c squared, so you always have to analyze and look which one is the longest side of the right triangle, and then which one am I looking for, and which one. But these two can be either or, because addition doesn't matter where you put the numbers, right? But so in the formula, this is A, this is B, and this is C. So A, B, C, A, B, C, A, B, and C. And then let's use it. So in this one, let's do number 1 first. So we have A, so that's 17 squared plus, we're looking for B equals, and then we have C. And then you just solve. It's a little blurry here. Let me just fix it. Okay. So then now the next step is to find the square. So that's 17 squared. Use your calculator. You can use your calculator if you have an iPhone. Turn it over, and that x squared right there, that's the one that you can use. So let's look for it. Okay. So we have 17 squared, that's 289, plus b squared, and then 19 squared, that's 361. And then you solve an equation. So this is a one-step equation here. So minus 289, combine like terms, 289. You want to leave this one isolated, right? That goes away, and then I have b squared equals 361 minus 289, that's 72. And then at this point, you're going to take the square root because you want to undo that thing and just leave b by itself. So the square root of 72 is 8.49. Now, this is approximately, right? Because there's a bunch of numbers for the decimals, right? So we just round, usually round to the first or second decimal point. That's okay. All right, let's do number 2. So when we're looking for c squared, so we have a squared, so that's 13 squared plus 5 squared equals c squared. All right, so 13 squared is 169 plus 25 equals c squared. 169 plus 25 is 194 equals c squared, and then you take the square root. The square root of 194 is 13.93. So C equals 13.93. So notice, and it's approximate, right? So that's the symbol for approximate. Notice that my C, because I have B and A, my longest side has to be bigger. So in this case, it makes sense. So a lot of the times you have to analyze what you're looking for. So B here has to be definitely smaller than 17 and definitely smaller than 19. So it's 8.49. So that makes sense. So the longest side has to be the longest here. We already looked for C. This is similar to this one. And here you're looking for A. This is similar to this one. So you're going to subtract. Here, notice you subtracted. Here you add it. So remember that, okay? All right, so what happens if you have just the values? Well, it's the same thing. You're always going to use a squared plus b squared equals c squared. And then just plug in the values that you have. You have A, you have B, you're looking for C. So that's A, so that's 12 squared plus 5 squared equals C squared. And then that's 144 plus 25 equals C squared. 144 plus 25 is 169 equals C squared. You take the square root to undo that. So that C equals 13. And that's it. So notice that 13 is bigger than 12 and 5. So that's good. So you always have to kind of check your answers. So it doesn't make sense. All right, on this one, you're looking for B. So you have A. So that's 8 squared plus B squared equals C squared, which is 10 squared. And then that's 64 plus B squared equals 100. And then you subtract 64 on both sides to combine like terms. B squared equals 36. Take the square root and B equals 6. Notice that B is smaller than A and smaller than this one, which is fine. Okay, so these are interchangeable, A and B. It doesn't matter because addition is commutative. So 2 plus 3 is 5 and 3 plus 2 is 5. So it's the same thing. Now, the one that you have to be careful with is C. Where are you going to put that one, right? All right, so let's do the last one here. So we're looking for A. So that's A squared plus 40 squared equals 50 squared. So 40 squared, so that's 1600. So that's 8 squared plus 1600 equals 2500. Sometimes you deal with these big numbers. So we subtract 1600 on both sides to combine like terms. That goes away. A squared equals minus 1600. That's 900. And then you take the square root and A equals 30. And that's my answer for A. Notice that A is smaller than B, so it makes sense. So these two make sense because this one is bigger. Okay? All right, I hope this helps.